Hi, this is Mary, and this is another magical math moment. This video is designed for my Algebra 2 students. There might be some relevant stuff here for Algebra 1. We're going to be looking at simplifying rational expressions where you've got a monomial over a monomial. So kind of simple, but a nice refresher for Algebra 2 friends. Okay, so in the first one, I'm looking at 35 over 14. There's nothing I can do to reduce that fraction, so I'm going to leave that alone. But I am going to look at the variables. So remember, when you are dealing with a situation like this, since the numbers don't reduce, I'm going to leave them alone. 2 minus 1 is 1. 2 is bigger, so I know my answer is going to be down at the bottom. So I've got y to the first down there. Same thing here. I'm looking at my z's. 2 minus 1 is 1. 2 is greater, so z is up here. Now, another way you can do this is if like you're looking at these y's, you could do this as y to the 1 minus 2, which is y to the negative 1, which is how come it ends up down there. All right, that's your answer. That's all you gotta do. Let's look at another one. So again, I'm gonna look at the numbers first. I've got 9 over 24. 3 goes into 9 3 times, 3 goes into 24 8, so this becomes 3/8. Now, if you're struggling or you're having an off day or whatever it is, maybe you missed reducing fractions somehow. If you've got one of these calculators, it'll do it for you, which is really nice. So you can just type in 9 divided by 24 and then math, enter, which will give you the reduced fraction there of 3/8. So use that tip as you like. Here we have x squared over x. 2 minus 1 is 1. It's on top, so we have x up there. Y over y cancels. I'm left over here with z to the first over z to the third. 3 minus 1 is 2. This is bigger. It's downstairs. All right. Not too bad. Let's see what else there is. Okay. Oh, yay, we get to factor. Woohoo! All right, so I've got x squared plus x minus 20. So I guess I lied to you. These aren't just monomials over monomials, but we just have one fraction. So I guess that's what I was thinking of. We're gonna do another video later where you're multiplying two of these things, but not yet. So I'm looking at the numbers that multiply to negative 20, but add to positive 1. How about x plus 5 and x minus 4? When you multiply them, you get negative 20. 5 minus 4 is positive 1 in the middle. And I've got x plus 5 on the bottom. Now, here's the fun part. When you have terms like this, I should say binomials that are exactly the same, they can cancel. I'm left with x minus 4, and that's my answer. And you don't have to put it in parentheses, you can. I usually tend to, just because I think it looks nice, but you don't really have to. What I want you to avoid is trying to say, oh, x over x cancels. No, it absolutely does not, because this is a trinomial over a binomial, as opposed to when we were looking at stuff like this. Monomial over monomial, totally cool to reduce things where you can. If you're trying to reduce things in a situation like this, the binomials have to be exact, or the trinomials would have to be exact. Now let's pretend for a minute we had some numbers out here that reduced. Yeah, we can totally do that because it's all being multiplied. These terms are being combined, added and subtracted. So hopefully that makes a little sense for you in terms of the difference. Okay. Oh, look, it's the difference of two perfect squares. Okay, the square root of y squared is y. The square root of 36 is 6. I'm gonna also have y minus 6 here, right? So you take the square root of the first term, square root of the last. One's positive, one's negative. On the bottom, I'm looking for the factors of negative 6 that add to negative 5. So be careful with this. This is a sneaky one. Y minus 6 and y plus 1. A lot of people jump right to negative 2 and negative 3, but that multiplies to positive 6, so be careful. Negative 6 plus 1 is negative 5. Negative 6 times 1 is negative 6. Now the fun part, if there's anything that's exactly the same on top and bottom, you can go ahead and cancel it out. So look at this, ha 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 ha. I am left with y plus 6 over y plus 1. Make that longer. Now, I hope you're not thinking, oh, that cancels out and it's 6. No, absolutely not, because this is a binomial over a binomial. Okay, one more. Ew, this is gonna be one where I can factor GCF out of the bottom, and then I can reduce numbers on the outside like I mentioned a minute ago. So let's see if we can figure this out. I can't do anything up here yet. I'm gonna leave it alone. On the bottom, 21 and 49 are both multiples of 7, so I'm gonna factor out a 7 here. I'm also looking at a squared and a. I have to choose the smaller of the two, a. Same thing for b and b squared. I'm gonna bring out a b. Okay, 21 divided by 7 is 3. A squared divided by a is a. B divided by b cancels. I don't have anything left with b's there. Plus, 49 divided by 7 is 7. The a over a goes. B squared divided by b is b. Okay. I'm hoping now that when you look at this, you're seeing a 7 over 7 outside. It can cancel. A squared over a can also be reduced to an a on top. B to the third over a b to the first. 3 minus 1 is 2. 3 is bigger, so b squared up top. And then I'm left with 3a plus 7b on the bottom. It's a binomial. I like to put it in parentheses. Now, in case you're thinking, wait a minute, Mary, a minute ago you said we could only do it if the binomials were the same. That's true. However, monomial over a monomial, which is how we started this whole video. I hope that this helps you a little with reducing rational expressions, and this will help you when you get into the next piece in Algebra 2 when you're multiplying these things. Thanks so much for watching. Look forward to seeing you next time. Bye.